Hello everyone, welcome to Wisdom Showers Mathematics and Physical Science YouTube channel. And today we're looking at a class test on some of the trigonometric um, identities and trig functions and reduction formulas as per term 1 topic. So this is a class test that I want us to do or to look at. So, number one, say simplify as far as possible. Simplify as far as possible. All right, we're given sine 180 minus 2x multiplied by tan 45 or tan negative 45 with a cos x minus 90 degrees. Right, number one. So if we have sine 180 minus 2x multiplied by tan minus 45 degrees all over cos x minus 90 degrees. And they say simplify as far as possible. Well, normally they don't just say simplify as far as possible, but they just say simplify. Right, in here you have to simplify the following trig uh, ratios and trig ratios that involve reduction formulas. Basically, we have to simplify these according to reduction formulae, cofunction, and since this is for grade 12, including double angles and compound angles. Right, here's the steps on how to do this. First, on our right hand side, I always advise learners to put in the angles that they see. Right, we see 180 minus 2 times an angle, and we know that all students taking coffee, um, the angle 180 minus 2 times an angle is found somewhere in the second quadrant. How do we know? This is 90, this is 180, this is 270, and 360, 0, and so forth. So we have 180 minus an angle theta in this quadrant. We have negative angles in this quadrant. We also have 90 minus an angle theta, which belongs to the cofunctions. And how am I guided? I'm guided by the angle in here, which is minus an angle 45, and then this x minus an angle. So if I have to put it into correct form, it'll become somewhere, or if I add 180 in it, it's gonna become a 90 plus or a 90 minus. Or if I add 360 to it, because it's an angle less than 0, but it forms an acute angle. This cos x minus 90, possibly if x is below 90. All right. Now, what do we look at in reduction formula? So we look at my small Cartesian plane here, and then writing down what is 180 minus, in what quadrant is 180 minus an angle in? That's quadrant number 2. Now, what is this value or sign of this trig ratio in quadrant number 2? The sign is a positive sin of this angle here, and it's sin of 2x multiplied by, well, how do we deal with negative angles? We deal with negative angles in the fourth quadrant. Now, when we have negative angles like tan of negative theta, it means this is negative tan of the theta, but here we have 45, so negative tan of 45 all over. Now cos of, this is what I do when I have the rearranged format whereby it starts with a variable and followed by a angle. I will rearrange and factorize. By rearranging, I mean writing it into minus 90 plus an x. Then in the next step, I write sin 2x into minus tan 45 all over cos. Now I factor out a negative. This is where I like it. When I factor out a negative here, it becomes a 90. And I factor out a negative here, it becomes negative x. Now, what did I say about negative angles? Negative angles are found in quadrant 4. So this is a negative angle. This whole 90 minus is a negative angle. But negative angles don't affect cos because cos in the fourth quadrant is a positive value. So let's look at sin 2x multiplied by negative tan 45 degrees all over positive cos of 90 minus x. Now, cos of 90 minus x is a cofunction. If we can go back here, 90 minus x. Then we are in grade 12, where sin of 2x is a double angle that gives 2 sin x and cos x. So this is 2 sin x cos x being multiplied by negative tan 45 degrees all over. Now, with cos 90 minus x, first look, cos 90 minus x is in the first quadrant where all students are taking coffee. And this is a cofunction of cos. What is the cofunction of cos? The cofunction of cos is sin. Now, what is the value of the sign for cos in the first quadrant? It's a positive one. And therefore, it will be a positive sin of the angle here, which is sin x. Now we are having multiplication throughout, so it will be safe for me to divide this and that. And now let's look at this. There is a video where we were doing special angles, and I explained that if you're having 45 here and a 45 here and a 1 and a 1, this becomes square root of 2, but we're looking at tan 45. Now tan 45 is the opposite over adjacent. Therefore, this becomes 2 times a negative 1 over 1 all over a 1, which is equals to, oh, forgot the cos here, with a cos x. which becomes negative 2 cos of x. That's our number 1. Number 2 says given sin 22 cos 12 equal to A, sin 12 cos 22 equal to B, cos 22 cos 12 equals to C, and sin 22. Why am I saying sin? Sine 22. Sine 12 equals D. Express the following in terms of A, B, C, and D. Now, in 2.1, they give us sine 34 degrees, and in 2.2, they give us cos 10 degrees. Right. Let me rewrite the whole question. Number 2, you're given sine 22 degrees cos 12 degrees equals to A, and sine 12 degrees cos 22 degrees equals B, and cos 22 degrees cos 12 degrees equals to C. And then sine 22 degrees sine 12 degrees equals to a D. Then express in terms of A, B, C, and D with 2.1, which is sine 34 degrees. Now, 34 with 22 and 12, 12 and 22, how does that merge? We have 12, 22, and if we sum these up, they give us 34 when we add them up. So, this basically means this is like sine of 22 plus 12. I know I added upside down, but yeah. Now in grade 12, there is compound angles and double angles. Now the compound angle for the addition of two angles for sine states that if sine of alpha plus beta can be expressed as sine of alpha cos of beta plus cos of alpha sine of beta. And therefore, in this case, what I'm talking about is this. So I'm just going to change color. If you have sine of alpha plus beta, you can express it as sine of alpha cos beta plus cos of alpha sine beta, of which in our case alpha is 22 degrees, beta is 12 degrees. So we can take it back here to say this is equal to sine 22 degrees cos 12 degrees plus cos 22 degrees sine 12 degrees. Now, I'm just going to take this down here. Sine 22 and cos 12 were given as A, and cos 22 sine 12 was not given, but sine 12 times cos 22 was given. So this means that we need to rearrange what's on the right here. Must rearrange that so that it fits. So this is sine 22 degrees cos 12 degrees plus um, plus so if we rearrange We don't have to rearrange what we're given here. So we can just simply rearrange this one here and this one here so that it fits cos 32. In order for us to have this being equal to an A and that being equal to a B. Right, in 2.2, 2.2 wants us to express cos 10 in terms of A, B, and C. Cos 10, cos 10. 2.2 is cos 10 degrees. What is cos 10 degrees equal to? Right, cos 10 degrees. We are given 22 and 12. Now, 22 degrees, 12 degrees. How do we get a 10 degrees? By subtraction. So if we subtract these two, meaning this would be cos of 22 degrees minus, minus 12 degrees. Therefore, the compound angle formula for cos, for two angles being separated with cos, says this cos of alpha minus beta is equals to cos alpha cos beta plus sine alpha times sine beta. Therefore, here we will have cos 22 times cos 12 plus sine 22 times sine 12. What were we given for A, B, C, and D? Sine 22 and sine 12, cos 22 and cos 12. S, C, and D. So I think this made a slight error there. This is 12 instead of 22 and 22. Right, so we're going to use C and D to express them. So this will be equal to a C plus a D. Right, back into our question. Number 3, it is known that 13 sine alpha minus 5 is equal to 0 and tan beta is equal to minus 3 over 4, where alpha is between 90 degrees up to 270 and beta in the same interval 90 to 270. Determine without using a calculator the values of the following cos of alpha and cos of alpha plus beta. Alright, let's see how we break that down. You are given number 3. You are given 13 sine alpha minus 5 equals 0, and you're given tan beta equals to minus 3 over 4. And they tell you alpha is an element of 90 degrees to 270 degrees. And beta is in the same interval 90 degrees to 270 degrees. Right. This can be done by a grade 10, 11, and 12 learner. Before we get into what do they require in 3.1? We must first simplify both of these into a right angled triangle, or as they are angles alpha and beta fit in an acute angle. Alright, we have 13 sine alpha minus 5 is equals to 0. This becomes 13 sine alpha is equals to positive 5 because the 5 goes across the equal sign and becomes positive. And then after, you can divide by 13 on both sides such that you're going to have sine alpha being equal to 5 over 13. 5 over 13. Now, from SOHCAHTOA, we know that sine is the opposite over the hypotenuse. And then, if we may look here, 90 is here, 180 is here, and 270 is there. We're looking at the 2, this in this quadrant, and the value here for sine alpha is a positive value. Where is sine positive in this quadrant? And where in the quadrant of 90 up to 270? So where we have two ticks, that's the quadrant we're going to draw our right angled triangle. Then the opposite side will be 5 and the hypotenuse side will be 13. Now we're left with one unknown. And how do we get that unknown? Using Pythagoras theorem, saying x squared plus y squared equals to r squared. We're looking for x squared, which is equals to r squared minus y squared. Now, x squared equals to r squared minus y squared can be taken under the square root. And once we take a square root, this means that the answer you're going to get is going to be plus or a minus of that square root r squared minus y squared. And thus, we are going to have plus or minus of the square root of 13 squared minus 13 squared minus 5 squared. And if we check the value of that, I know they said without using a calculator, but to make things faster, you can take the square root of open bracket 13 squared minus 5 squared, because time is something you want to save in paper too. Then it's a plus or minus 12. Now we are in the second quadrant, and the x value should be positive or negative, and I know it should be negative, so x is equals to negative 12. Now we go to 3.1. What did 3.1 want from us? 3.1 wanted from us the value of cos alpha. The value of cos alpha is given by an adjacent over a hypotenuse. Now the adjacent side here is a minus 12 over 13, which is the hypotenuse. 3.2, on the other hand, wants the cos of alpha plus beta. Now, how are we going to get that? We were given tan beta is equals to minus 3 over 4, so we must find what information is given to us here. Tan beta is equals to minus 3 over 4. We know tan is what? Opposite of adjacent. And we're looking at this quadrant from 90 to 180, to 270, where this is 180. And tan is negative in this quadrant, and we want the quadrant between 92 to 70. So the one with the most ticks gets the sketch. I forgot something here to mention that the angle alpha is found from here to here, which then becomes acute inside here. That is alpha, and that is alpha. And same story here, the angle beta is found from here to there, which then becomes acute due to reduction. And that's beta dot alpha, a beta. All right. Now we want to find opposite side here are positives, but the adjacent side here is a negative. So therefore this would be minus a 4 with positive 3. Thus giving us x squared plus y squared. We're looking for r squared. Now our x is a minus 4 squared plus 3 squared, which is equals to r squared. Now that's 16 plus 9 equals to r squared. We're looking for the value of r. So this is 25 is equals to r squared. If we're taking the square root now, r is equals to plus or minus a 5. But we know the r value is a positive value. So r is equals to positive 5. Now, we were not tasked to get positive 5. We were tasked to get the value of cos alpha plus beta. But what is the value of cos alpha plus beta? In your formula sheet, you're going to find this compound angle cos alpha plus beta. It is expanded to cos of alpha times cos of beta minus sine of alpha times sine of beta. And if I go back here, we have found the value of sine cos alpha, we have found the value of sine alpha. The only ones we don't have is cos beta and sine beta, but we do have the angle beta, so we can rename here. This is 5, and we'll be able to give the value of cos beta, which is the adjacent side, minus 4 over positive 5, and sine beta, which is equals to the opposite side being 3 over 5. Now we have every value here. Cos of alpha was from the previous question, and it was a minus 12 over 13 multiplied by cos of beta is a minus 4 over 5 minus sine of alpha was the first one we had, which is 5 over 13 multiplied by 3 over 5. Now, these two are going to divide each other, or let's not divide them. Let's just do mathematics. If we're trying to do grade, I think it's grade 5, 6, 7 mathematics, we take our lowest common denominator as 13 times 5. Now, if 13 times 5 comes in here, 13 and 5 come in there once. Therefore, it's going to be 1 times negative 12 times negative 4 becomes a positive 48 minus 13 and 5 come here once, and then that'll be 1 times 5 times 3 which is 15. And therefore, we get uh, 33 when we do the subtraction over 65. And that was without using a calculator. Right, last question. Well, it's not the last. Prove without using a calculator that if sine 28 is equals to A and cos 32 is equals to B, then B root of 1 minus A squared minus A square root 1 minus B squared is equals to a half. Is equal to a half. So we're proving the left hand side with the right hand side being given the keys. Okay, I am going to look at it this way. Now, it's question 4, right? Says if sine 28 degrees is equals to A and cos 32 degrees is equals to B, then B square root of 1 minus A squared minus A square root of 1 minus B squared is equals to a half. Now we have to prove what the left hand side is all about. The left hand side is all about this minus A square root of 1 minus B squared. Okay, so where there is A, we can put sine 28. Where there is B, we can put cos 32. So cos 32 degrees square root of 1 minus sine squared 32. Or we can just say 1 minus open bracket sine 32 squared. But we know sine 32 squared can be written as sine squared 32. Then minus sine 28 degrees square root of 1 minus cos squared. Why am I saying sine 32 when it's sine 28? Right, then it's cos 32 degrees. All right, we also learned with identities that we can write 1 minus cos of theta as sine, 1 minus cos squared theta as sine squared theta, and 1 minus sine squared theta as cos squared theta. Right. This means we have cos 32 times sine square root of cos squared 28 degrees minus sine 28 degrees with the square root of cosine squared 32 degrees using that identity. Now, cos 32 degrees can be written as the square root of cos 28 degrees squared minus sine 28 degrees times square root of sine 32 degrees squared. Now the square root is going to rationalize, if I can call it, cos of 32 then becomes times cos of 28 minus sine 28 times sine 32 degrees. Now this looks like one of our what do we call them? compound angles, but on the sine ratio side, it should be well ordered as cos 32 degrees, cos 28 degrees minus sine 32 degrees, uh, sine 28 degrees. And this comes from when we have the cos of alpha, cos of beta minus sine of alpha, sine of beta comes from cos of alpha plus beta. So we may rewrite this red one in terms of this, in terms of this one. So where alpha is going to be 32 and beta is that. So this is cos of 32 degrees plus 28 degrees, which is equals to cos of 60 degrees. Now, we also did a video whereby we were defining our special angles 60, 30, and we had 1, 2 here and root of 3. You can check it in our channel. This is square root of 3. That cos of 60 is adjacent, and the adjacent side is 1 all over the hypotenuse side, which is 2, therefore which is equal to the right hand side. Now, thank you for watching our short, long trigonometry identity and trig ratios video for grade 12. Please like, share, and subscribe.